This video explores single replacement reactions, and single replacement reactions are a particular pattern of reaction that we find in chemical reactivity. In order to do well with this topic, you'll want to be familiar with what an ionic compound is and how to write out and balance a chemical reaction. The metaphor that I think of when I think of single replacement reactions is ballroom dancing. And if you think about a couple who is preparing to dance, and you have someone who is the follow and someone who is the lead, we'll just label them that way, and someone else wants to come and cut in. Let's say this guy right here wants to cut in on this couple over here. Since he is a lead, he would cut in the lead position, not in the follow position. So when we talk about single replacement, we're talking about a compound and an element, and the element is coming in and bumping out someone in the compound and taking their place. So this is the type of reactions you might see. You might see sodium reacting with magnesium oxide. And you'll notice here that sodium is a metal, and that in magnesium oxide, magnesium is the metal, and oxygen is the nonmetal. So using our dancing metaphor, the metal will come in and bump out the metal, the thing that it's like. Now, when sodium comes in and bumps out magnesium, it's going to form a compound of sodium and oxygen. And we know that sodium has a charge of +1, while oxygen has a charge of -2. So my new compound that's formed from sodium and oxygen, sodium oxide, will be Na2O. And I bumped out the magnesium, so it will be hanging out by itself. And then my last step will be to go back and balance my chemical reaction. In my second example over here, I have chlorine, which is a nonmetal, reacting with lithium nitride. Lithium is the metal, and nitrogen is the nonmetal. So since chlorine is a nonmetal, it will come in and bump out the nonmetal. So that means I'll be forming a compound between lithium and chlorine. Lithium has a +1 charge, chlorine has a -1 charge, so I'll be making lithium chloride, which has a formula of LiCl. I bumped out nitrogen, and nitrogen we know is one of the silly 7. It's a diatomic element, so when it's by itself, it shows up as N2. Chlorine is a diatomic as well, that's why we have that 2 sitting there in the reactants. So I end up with Cl2 plus Li3N goes to LiCl plus N2. And my last step is to balance this, and I'm probably going to need 2 lithium nitrides, which will mean I need 6 lithium chlorides and 3 chlorines to balance that reaction. So you can see that there's a general pattern here. I have some kind of element reacting with an ionic compound. And if the element is a nonmetal, if A is a nonmetal, then it will bump out the nonmetal. So I will end up with Ba plus C. But if A was instead a metal, then it would come in and bump out the metal, which in an ionic compound, the metal is always written first. So I would end up with AC plus B. Let's take a look at an example together. Write out and balance the single replacement reaction between calcium oxide and lithium. So I have calcium oxide reacting with lithium, and what I want to do here is identify the lithium. Is it a metal or a nonmetal? Well, it's a metal, and then I look back over at my calcium oxide and see calcium is my metal, so lithium will come in and bump out the calcium and pair up with the oxygen. We know that lithium has a +1 charge, while oxygen has a -2 charge, so my formula will be Li2O. The calcium now is hanging out by itself because it got bumped. I end up with 2 lithium, and my reaction is balanced. do another one. Oxygen and strontium bromide react in a single replacement reaction. Write out and balance the reaction. Well, we know that oxygen, when it's by itself, is a diatomic molecule, so it shows up as O2. Strontium bromide, the formula is SrBr2. We know that oxygen is a nonmetal, so it will come in and bump out the nonmetal in strontium bromide, which is the bromine. So we'll come over and replace that. We know that strontium from our periodic table has a charge of +2 and oxygen has a charge of -2. So strontium oxide will have a formula of SrO. I bumped out the bromine. Bromine is a diatomic element when it's by itself, so I end up with +Br2. I end up needing 2 strontium oxides and 2 strontium bromides and 2 bromines to keep the whole thing balanced.